Okay, so in this video we're just going to do a quick tutorial on the basics for actually using Axon. If you already know Axon, then you can skip this video. You don't really need to know much to use the tools for data validation, but probably does help to know a couple of the basics. So Axon is an extremely simple language for manipulating haystack data. So once again, we're going to enter our interactive shell here. You can hit question mark to see your core functions or help all to list all of the functions. So your basic literals are pretty much like all programming languages. You have true and false. Strings are double quoted. And then numbers can be floating point. But what's unusual about Axon is that numbers can have units. Okay, and units matter when we try to add things together. So for example, if we try to add 123 kilowatts to 34 meters, we're going to get a unit error. Okay, or we can do likewise. If they are the same unit, then we can add them together. There is some functions to convert things. So for example, if we want to convert from kilowatts to watts, we can do that, and vice versa. Okay, the megawatts, etc. Okay, so that's using the to function. There's also the as function, which will just basically can strip the units if you want to strip them. Okay, so Booleans, numbers, strings, URIs are with the backtick, just like Zinc. And then we have literals for dates and times. So for example, today is just the date. And likewise, we can do times. And then there's a function called datetime to create timestamps. Okay, so those are our basic scalar types that we're going to use in Axon. For the most part, we're going to use strings and numbers. But if we do want to get into collection types, there's 3 collection types in Axon, as is in their haystack. So we have lists, which are with the square bracket. So that would be a list of numbers. We can do a list of strings too. And then we have dictionaries, which are curly braces. So I could say Brian, and I can just say I'm a person. And if I leave off the colon, then it's assumed to be a marker tag. And so anything in curly braces is a dictionary. And then lastly, we have grids, which typically you'll use the toGrid function for that. So we can always turn a dictionary into a grid, and then it will be displayed as a table. So those are your basics in terms of your data structures. You got those scalar values. You got these 3 collection types. As we showed you, you also now have data types, which we have in our using statement. So for example, capital D dictionary is the data type for dictionaries. We've also imported Project Haystack. So we could say, you know, for example, let's get an air handler is subtyping from air handler equipment with the AHU tag. Okay, so in a previous video, you saw how you can actually import other additional Zeta libraries into your namespace. Okay, lastly, I just want to take a quick look at functions so you understand the function invocation syntax. So a function with no parameters looks like this. Actually, let's make it a function that adds 2 numbers together. So it's going to be your parameters and then the body of the function. So we say x and y go to x plus y. And I've assigned this function to a variable called f. Okay, so now I can call f with 4 and 6, say, and that's going to evaluate to 10. Okay, in the shell, if you do want to do multiple lines, you can enter do, and you'll see we'll go into multi-lines here. So I'll say x plus y. I could have multiple things here. Actually, let's say z is x plus y, and then let's turn z squared. And then once I am done my multi-line expression, I can just hit enter again, and it'll evaluate that. So let's try g with 3 and 4. That's going to be 7 times 7, and we'll evaluate that. So very simple function syntax, similar to most languages. So one of the things that is maybe a little confusing to new timers about Axon is the function invocation syntax. So we can see here I'm just calling a function with the parameters, which is sort of the standard way most programming languages do it. So let's say now. Okay, so now is a function. If I just evaluate it with no parentheses, I'm evaluating the function itself. If I add the parentheses, I'm going to invoke that function, and I'm now going to get a date time. So then we could use the, let's say, the date function and get just the date portion of now. Okay. Likewise, I could get just the year portion from the date like this. Okay, and you see this sort of in Lisp style. There's lots of nesting of functions. Axon does support a dot notation, which just lets you basically unwind these nested functions and chain them using a dot. So, for example, I can say now, and then I can pipe that to the date. Okay, and this syntax here, okay, with the dot notation is exactly the same semantics as this. There's no difference. And you'll see me typically when I'm showing you examples using either or syntax. But there's no difference between that. And likewise, I could pipe that to year. Okay. Now, in this case, I could have put the parentheses here. It doesn't hurt anything. But if it is a function that only takes one argument, you can leave the parentheses off as a convenience. So that is your whirlwind tour of Axon. All you're going to really need to do is basically probably put in some literals, maybe a couple little function calls with dictionary literals or list literals. For the most part, that's all you're going to need to know for working with this. If you do want to look at all the docs for the Axon, they're all on haxel.io, and you can see some of the other features I didn't cover. But there's actually not too much more. It's an extremely simple language. So that wraps up your whirlwind tour of Axon.